In this lesson, we're going to talk about solving quadratic equations using factoring. So my first question to you is, why can't we solve these like a normal equation? Let's start with x squared plus 2x minus 24 equals 0, and let's try to solve it like a typical equation. If this were a linear equation with just an x, I would add 24 to each side. So then I have x squared plus 2x equals 24. The problem is these are not like terms, so I can't combine those. Some of you might notice your exponent here and think, well, maybe we could do the square root of both sides. The problem is the square root of x squared is x, but what's the square root of 2x? I have to leave that as the square root of 2x, and then that's equal to the square root of 24. This just starts to get really messy, and we can't solve these equations in this way. What we have to do is use factoring. So let's start with a review of our factoring. When we're ready to factor, what we're doing is turning this into two binomials that multiply together to give our expression. Notice there's no equal sign yet. We're going to add that in later today. You want to start by looking for an overall GCF. Is there anything that x squared, 2x, and negative 24 can all be divided by? There is not, so I'm ready to start factoring. I need to identify my A, my B, and my C. A is equal to 1, B is equal to 2, and C is equal to negative 24. We multiply A times C, so 1 times negative 24 is negative 24, and I'm looking for two numbers that multiply to give me negative 24. Well, there's a lot of options here. 1 and 24, 2 and 12, 3 and 8, and 4 and 6, and then some version of a negative in here somewhere. So I need some way to narrow down these options. Well, remember, I am replacing that B term. I need to replace the B term with whatever these two things are. So I need these to add to be 2. If I make the 1 a negative, negative 1 plus 24 is 23. If I make the 24 a negative, negative 24 plus 1 is negative 23, so it can't be that one. If I make the 2 a negative, negative 2 plus 12 is 10. And if I make the 12 a negative, negative 12 plus 2 is negative 10, and so it can't be that one because it doesn't equal 2. For 3 and 8, if I make the 3 negative, negative 3 plus 8 is 5. If I make the 8 negative, negative 8 plus 3 is negative 5. That also does not equal 2, so it must be some combination of 4 and 6. I need this to be positive 2, and I need to multiply to be negative 24. Only one of these can be negative to make negative 24. The larger number has to be positive, so that means that my 4 has to be negative there. Now I'm ready to rewrite. Remember, I'm replacing my B term with these two numbers that I came up with. So this should become x squared. I like to put the negative first. It causes me to make fewer negative mistakes. X squared minus 4x plus 6x minus 24. The point of doing this is that now I have my four terms and I'm ready to factor by grouping. The common factor for x squared and negative 4x is x. X squared divided by x is x. Negative 4x divided by x is negative 4. The common factor for 6x and negative 24 is 6. 6x divided by 6 is x. Negative 24 divided by 6 is negative 4. I know I've done this correctly because the two parentheses match. That's my new common factor. I factor that out, and that leaves me with what's left in front of the parentheses, x plus 6. So my two factors are x minus 4 and x plus 6. You're going to need to be able to factor today to be able to move forward in this process. So when we graph these equations, quadratic equations graph a curve called a parabola. That curve has some x-intercepts. We're used to just having one x-intercept. Now sometimes we're going to have two. Those are called our zeros because they're where y is equal to 0. These zeros are 1, 0, and 3, 0. There are x-intercepts. When we solve quadratic equations using factoring, these are what we're finding. We are finding those zeros. So eventually we're going to work our way up to actually graphing these parabolas. In order to do that, we need a new property. So we're already familiar with the distributive property. Today we're going to learn about something called the zero product property. The zero product property tells us that if we have two quantities multiplied together to make 0, either one or both of them must equal 0. So in this case, I have 4 times x equals 0. Well, I know 4 can't be 0, so I throw that out. X could be 0, though. In order for 4 times x to be equal to 0, I know that x has to be 0. It's the only option. But for one like this, I have two quantities together equal to 0. Either x could be 0 or y could be 0. Both of those solve the equation and make it equal to 0. It doesn't have to be both, but it can be. So let's put all this together now. To solve an equation using factoring, I want to start by putting my equation in standard form, which essentially just means make it equal to 0. So I need to get everything on the same side of the equal sign. So I draw my line down. In order to make 0 on this right-hand side, I'm going to subtract 8 from each side. And that leaves me with x squared plus 2x minus 8 equals 0. This is standard form. I have my x squared term first, then my 2x, then my negative 8, and it's all equal to 0. Now I'm ready to do my factoring. A is 1, B is 2, C is negative 8. I'm looking for something that multiplies to be A times C and adds to be B. In this case, 1 times negative 8, no. 2 times 4, that might work. 2 times 4 makes 8. I need one of these to be a negative, and I need them to add to be positive 2, so that must mean that my 2 has to be negative. I'm going to rewrite my B term now. The A term stays the same. I replace B with negative 2x plus 4x and bring down the minus 8. I'm ready to factor now. I need two groups. The GCF of the first group is x. 1x squared divided by x is x. Negative 2x divided by x is negative 2. The GCF of the second group, 4 times x minus 8 is 4. 4x divided by 4 is x. Negative 8 divided by 4 is negative 2. I know I've likely done this correctly because I have my new common factor, which is x minus 2, and that leaves me with x plus 4. And don't forget, this was all equal to 0. I could have brought that down all the way down here, I just didn't. So I started by putting it into standard form by making the equation equal to 0. I factored the expression. Now I'm going to use that zero product property to find the zeros. I have these two quantities that are multiplied together to make 0. One or both of them has to be 0. So I'm going to make them equal to 0 and see what happens. Add 2 to both sides, so x equals 2. Subtract 4 from each side, so x equals negative 4. So my zeros here are 2 and negative 4. If I were to graph this parabola, it would cross the x-axis where x is 2 and where x is negative 4. Let's try another one. Let's start by putting our equation into standard form. We're going to start by getting everything on the left-hand side and making this equal to 0. I can add 8x and I can add 6 to both sides. None of those are like terms, so this becomes 2x squared plus 8x plus 6 is equal to 0. Now we are ready to factor. Don't forget that we can factor out an overall GCF. I have an overall GCF of 2, so I'm going to factor that out by dividing everything by 2. So that becomes x squared plus 4x plus 3, and it's still equal to 0. 2 is now one of my factors. I'm not going to forget about it, but I'm not going to use it for just a second. I'm going to factor the other expression, the 1x squared plus 4x plus 3. I'm looking for two things that multiply to be a times c, 1 times 3 is 3, and add to be 4. Well, the only thing that multiplies to be 3 is 1 and 3, and 1 plus 3 is 4, so those are my replacement terms there. So this becomes x squared plus 1x plus 3x plus 3. Remember, I just replaced my b term, the 1x squared came down, the 3 came down. I'm ready to factor now. Group these two together and group these two together. X squared and 1x have an overall GCF of x. X squared divided by x is x. 1x divided by x is 1. This has an overall GCF of 3. 3x divided by 3 is x. 3 divided by 3 is 1. The overall magic has happened. We've got x plus 1 for both, so that's our new common factor. And that leaves me with x plus 3. Don't forget, we had our other common factor, which is a 2. We just need to bring that down here at the end. So now I have 3 factors. Remember, I'm going to use that zero product property to find the zeros. So I'm going to make 2 equal to 0. I'm going to make x plus 1 equal to 0. And I'm going to make x plus 3 equal to 0. 2 is not equal to 0. There's no way to make that equal to 0, so we just throw that out. For this one, though, we can subtract 1 from each side, so x equals negative 1. We can subtract 3 from each side, so x equals negative 3. So my zeros are negative 1 and negative 3. Let's do one more. Again, we want to start by putting that equation into standard form by subtracting 18 from each side to make that equal to 0. This becomes negative 2x squared plus 13x minus 18 equals 0. I'm looking for an overall GCF. Is there anything that 2, 13, and 18 can all be divided by? There is not. So now I'm ready to factor. I'm going to multiply a times c. Negative 2 times negative 18 is positive 36. I'm looking for two numbers that multiply to be 36 and add to be 13. 1 times 36, no. 2 times 18, no. 3 times 12, no. 4 and 9, ooh, that might be possible. I don't need any negatives here because these numbers are both positive. 4 times 9 is 36, and 4 plus 9 is 13. Sorry about that bell there. This becomes, I'm going to replace the b term with negative 2x squared plus 4x plus 9x minus 18 equals 0. I'm going to factor this into two groups here. The overall GCF of the first group is negative 2x. Negative 2 divided by negative 2 is positive 1. X squared divided by x is x. 4 divided by negative 2 is negative 2. X divided by x is 1, so those cancel out. The GCF of 9 and 18 is 9. 9x divided by 9 is 1x. Negative 18 divided by 9 is negative 2. Now I have the matching factors, so this becomes x minus 2 as our new common factor, and that leaves me with negative 2x plus 9, and that's still equal to 0. So I made it equal to 0, now I've factored, now I'm ready to use my zero product property. So I'm going to do x minus 2 equals 0, and negative 2x plus 9 equals 0. Add 2 to both sides, so x equals 2. Subtract 9 from both sides, sorry about the weird jump there. So negative 2x equals negative 9. Divide both sides by negative 2, so x equals a positive 9 halves. It is okay to have a fraction or a decimal as your final answer here. We can cross the x-axis at other places than just whole numbers, so a fraction or a decimal is fine there. Let's talk about a couple of applications here. Suppose we know that the area of a rectangle is 15 feet squared and that the length is 2 feet longer than the width. So let's start by drawing our rectangle. We're used to doing this type of problem with perimeter, but this time I want to do area, which means I'm going to be multiplying. I have a length and a width on my rectangle. This tells me that the length is, that means the length is equal to 2 feet longer than the width, which means I need to take the width and add 2. I can now replace L with 2 plus W. Remember, the area is 15 feet squared, so I need to do the width times the length. That's how we find area. I did the width times the length. The length is 2 plus W, and that's equal to 15. All right, I'm going to distribute this to start solving. So this becomes 2W plus W squared equals 15. I noticed that this is creating a quadratic, not a linear. I have a W squared and a W, which means I'm going to have to solve this using factoring. I'm first going to switch these two around so that I have the W squared first and then the 2W so that I can get it into standard form. And then I need to make this equal to 0, so I subtract 15 from both sides. So W squared plus 2W minus 15 equals 0. So I have created my equation. I've put it into standard form. Now I'm ready to factor. I'm looking for two numbers that multiply to be negative 15, but add to be W. Well, 1 and 15, no. 3 and 5 are possible, because if I would subtract those, I would get 2. I need one of these to be a negative. I need the larger number to be positive, so that's going to be a negative 3 plus 5. I'm now ready to rewrite this, so this becomes W squared minus 3W plus 5W minus 15 equals 0. I'm ready to factor, so I'm going to put these into two groups. The GCF of the first group is W, so that's W minus 3. The GCF of the second group is 5. 5W divided by 5 is W. Negative 15 divided by 5 is negative 3. These are my new common factors, so I factor that out. So that's W minus 3 times W plus 5 equals 0. Now I'm ready to solve. W minus 3 equals 0. W plus 5 equals 0. Add 3 to both sides, so I know that the width is 3 or the width is negative 5. But often when we have a word problem, we can throw one of these out. It's not possible to have a negative width, so I throw that one out and I make the width equal to 3. I know that the length is 2 feet longer than the width, so the length is going to be 3 plus 2, which is 5. So my dimensions of the rectangle, the width is equal to 3 and the length is equal to 5. I should always put my units on at the end. It's not feet squared because feet squared is area. Length and width are just feet there. Let's do one more application problem. Let's write our own quadratic equation that has zeros at -5 and 3. We're going to start by just doing this in reverse. I know that I have two zeros, x equals -5 and x equals 3. Well, I need these to be equal to 0 since they're zeros. So in order to get this equal to 0, I'm going to add 5 to each side here. The -5 and the +5 make 0, and that leaves me with x plus 5. For this one, I'm going to subtract 3 from each side, so x minus 3 equals 0. These are now my two factors. I have x plus 5 times x minus 3, and I'm going to multiply this. X times x minus 3 plus 5 times x minus 3. Remember, both of these things get multiplied by the binomial. I'm going to distribute x squared minus 3x. Distribute again, plus 5x minus 15. I'm going to simplify, so that's x squared plus 2x minus 15, and that is my quadratic equation. All this is just factoring in reverse. If I did this in reverse, I would take b, I would split it up into two groups. I would factor so that I get my two factors. I would use the zero product property to solve from there, and I would end up with my two zeros. It's the same set of steps, just in reverse. Sorry about the bell there again. In summary, to solve a quadratic equation using factoring, we're going to, number one, put that quadratic equation into standard form, where we make this ax squared plus bx plus c equals 0. We're going to factor, and then we're going to use that zero product property to find the zeros. Thanks so much. Have a great day.